So in this video we will study about the pH measurements and pH indicator. So pH measurement, in the laboratory we use this kind of instrument which is called pH meter, and pH indicators are usually pH paper. They, if you will dip in a different pH solutions, and they will give you different color. And cabbage is also used as a indicator that have some kind of dye that changes the color. When we treat it with the acid, it will give red color. When we add a base into the cabbage extract, basically you can cut the brown cabbage, boil into the water and strain it, and then that purple color solution act as an indicator, right? So let's talk about a little bit more about the pH indicator. The substance that have a different color at the different pH. So pH indicators are those compound or those substances that have a different color at different pH. Consist of the weak acid or weak base whose conjugate base has a different color. So what are the pH indicator? pH indicators are usually they are weak acid or weak base, and their conjugate base or conjugate acid have a different color. Here we abbreviate indicator as a IN and H. IN means hydrogen with indicator. Once it will be ionizes, for an example, if it is a red, once it will be ionizes, its conjugate base will be yellow. So the color in acid will be red, and in the base it will be yellow, and in between means somewhere neither you are in acid or maybe less acid and less base. So let's see some more example of this indicator. Here we have one indicator that is called the phenolphthalein. So phenolphthalein is this one. Let me zoom a little bit so that we can understand, readable. Okay, equivalence point for this phenolphthalein is exact neutralization. Exact neutralization means pH 7. So here is the equivalent point for the phenolphthalein. And end point color change indicator. End point means, what is the meaning of end point? End point means color changes of indicator. Indicators useful in titration when pH of equivalent point is within plus minus 1 unit of pKa. So this is important point, that what be the good indicator quality or property is it would be that the indicator useful in titration when pH of equivalent point is within 1 plus minus unit of pKa. And if you see this one, this graph, pH is increasing on the from bottom to up, and volume of HCl is increasing. So basically this is says that we are here in the strong base. We started from the strong base, and as we are reaching from the pH 10 to pH 8, in this region phenolphthalein changes, color changes interval. So this is the purple color between pH 8 to 10, and as we reach to the 6 to 4.5 or very near to the 4. So this region is for methyl red region. So phenolphthalein we can use only in this region. If we are going to do any titration which have the equivalent point lies between 8 to 10, then we can use phenolphthalein. And if we have any equivalent point which is lie in between the 6 to 4, then we will use the methyl red. So this is the meaning and how we are going to understand this pH indicator. So here you can see, if we are going to start with the phenolphthalein, So in case of phenolphthalein we have to start with the strong base and weak acid is here. So phenolphthalein is good, phenolphthalein indicator is good for weak acid and strong base titration, because once we will start the weak acid equivalent point will lie between around 9 or between 8 to 10, will be somewhere in the 9 pH. That is why we can see that titration is complete. And in case of methyl red, so the pH must be below 4.2 and or not more than 6. So here we have, this is called weak acid and might be weak base, because we are almost same. So if we are strong base, basically this is strong base. If we are using this methyl red, you can see we cannot get any equivalent point color, because its color change happen only in the acidic region. That is why we have to use methyl red for some other different titration. And what would be the other different titration? So methyl red indicator is good for the weak base and strong acid. For the weak base and strong acid, phenolphthalein is not good, right? And if you see the previous slide, that for the strong base and weak acid, methyl red is not good indicator. For weak acid and strong base, phenolphthalein is good indicator, because its color change will an equivalent point lie in the color change area. So this is very important to know the pH range of the color change for these two indicators and where they lie. So for this weak base and strong acid, titration equivalent point lies somewhere 7, near 7. No, it's around 5. It's around 5 in the acidic region. So these were the example of the indicator and selection of indicator, how we can select. So we always have to use the indicator to find out where the color is changing, and then based on the color changes we have to select particular indicator where your titration equivalent point is there, means the pH must match with the equivalent point of the your titration.